Hello, my name is Manuel Ignacio Ayala Chauvin, a professor at the Universidad Tecnológica Indoamérica. The topic that I will explain is underwater power generation based on gravity vortex siphon boost energy transitions. The index is Introduction, Method, Results, Discussions, and Conclusions. Now, Introduction. The need for the energy transition is nowadays undeniable. Climate change, fossil fuel depletion, and economic vulnerability are some of the main drivers of the model change. You can see here the CAD design and the real prototype, the turbine. Therefore, it's necessary to promote local energy generation in order to improve renewable energy transition. This paper presents the design, installation, and performance of an underwater turbine generator prototype with a gravitational vortex and siphon. You can see here in this picture all the parts of the system. Now, the development of the prototype was done in 5 stages: conceptualization, specifications, conceptualization, economic technical feasibility, detailed designs, and finally materializations and proofs. The gravitational vortex with a siphon uses the concentrated rotational energy from the center of a whirlpool, which consists of a vertical axis turbine, which is located outlet of the vortex for the energy production, and a siphon which serves to increase the head. Now, you can see here in this picture all the parts. The first is the inlet, after is the vortex, turbine, and generator, and siphon, and control, and outlet. You can see here the grid electric. Now, the generators converted mechanical energy into electrical energy. The electric power PELC was calculated by equation 5. Power electric is equal mechanical power and the performance. Now, the next results. The proposed underwater turbine was designed using computer design CAD. The complexity of the machines, number of parts, weight, and complexity of the sample was reduced before building the prototype. You can see here the computer design CAD, and you can see here materialization and the prototype. Results. The measurements were made with AR6 network analyzer from the company Circuitor. Our study case will experiment with a usual setting of 220 volts and 60 hertz. The following graphs show the measurements of different variables, like in this case, voltage, intensity, and frequency over the period 5 days and are really years. You can see here the voltage and the phase 1, phase 2, and phase 3. Now, the intensity, you can see here intensity over time. The intensity maximum under the load was 43 amperes in phase 2, and in addition, it's observed that when the loads are applied, the voltage and frequency values remain at acceptable levels, and the frequency over the period of 5 days, the frequency stays within a range of 60 hertz. You can see here the frequency. Now, results. According to the file measurements, the torque T decrease and the number of revolutions per minute N increase. You can see here the torque, and the torque decrease when the revolutions increase. And the total flow of the turbine is 0.21 meters per second, with the head difference 1 to 2 meters respectively. It gives approximately 7.5 kilowatts of usable electrical energy with an efficiency of 35 to 37% at the rotational speed. 1,100 revolutions per minute to 1,300 revolutions respectively. You can see here the power generation, and you can see here in this point there's set 0.5 kilowatts here. Now, a comparison between the experimental and calculation results for this underwater turbine in relation its performance is shown in the figure. Underwater turbine efficiency and showed the maximum values at the rotational speed 1,200 revolution per minute. The maximum experimental determined efficiency is approximately 37% or 0.37 efficiency here. Now, the return on investment will be realized in an average of 14 years. The profitability of the installation is around 7.5% per year, assuming that the electric company buys all the energy generated by the system. This is very important. Finally, conclusion: the papers introduce a low power underwater turbine generator that was developed to produce local and renewable electricity that can help in the path of the energy transition. The system was designed to provide the affordable access to the renewable electricity supplies to rural or isolated communities in Ecuador and other Andean countries, using the ubiquitous hydric resource that characterizes the region. In normal operating conditions, the efficiency for a head difference lighter than 1.5 meters is 30%. The total flow of the turbine is 0.8 and 1 meters per second, with the head difference of 1.5 to 2 meters respectively. It gives 7.5 kilowatts of usable electrical energy with an efficiency of 35 to 37%, with good supply quality and stability delivered to its loads. A good use of the system can achieve more than 5,000 hours and at full load, just like a conventional hydroelectric plant. Future scenarios on a different scales of implementation are suggested. Furthermore, this type of designs can be reproduced in another context in order to promote the decentralized generation and sustainability growth between the territory and its resource. Underwater power generated based on gravity vortex siphon generate green electricity to fund themselves and to make a contribution to environmental protection. Thank you very much.